this is, this morning, right, you heard from the ministry the need to accelerate digital transformation business, right? You also just heard from Gartner, the digital disruption that is driving this digital transformation, as well as machine learning, right? What I'd like to start off with is that I want to show you a short video clip on where IBM, or how IBM sees this world filled with digital transformation, disruption, machine learning, and artificial intelligence. Can we get the video going?
Hello, my name is Watson.
So, as you've heard, right, Watson is the IBM technology that enables our cognitive systems. So, you just saw that, the world that we believe today and the future will be with technologies like Watson and cognitive systems is a world that's going to be healthier, it's going to be safer, it's going to be cleaner, it's going to be a lot more personal, and it's also going to be a lot more creative, right? And if you look at that title here, Augmenting Intelligence, AI, we refer to AI as Augmenting Intelligence at IBM because we think that machines are there to be a trusted advisor to humans to make decisions, right? And what I'm going to do is that in the next 15 or 20 minutes, I'd like to share with you 3 points, or three things, right? First, I think we've got to understand what is actually the core of what is fueling this growth in machine learning, artificial intelligence, and cognitive systems. Second, I think it's important to understand why cognitive systems are better suited than existing traditional computing systems to partner with humans to help extend their expertise and knowledge. And third, I wanted to share a couple of use cases in different industries on how you can apply technologies like this to create competitive advantage. So let me just get started here. Now, if you go back 5 years, right, just about 5 years from now, you had gone back, would you have imagined that the world's largest taxi company owns no cars? Or that the world's largest accommodation provider owns no property? Or that the world's valued retailer has no inventory, and that the world's most popular media company has no content or creates no content? Now, how did these companies, who were all born in the internet, right, owning no real physical assets, disrupt entire industries. How do they do that? And there's really three things that combine to help them drive that disruption, right? The first is data. If you look at data, right, the sheer volume of data that is available. Yet, today you'll find that only 15% of this data and advanced analytics is being leveraged across organizations. The second is, the extensive use of APIs to connect consumers with providers, and this again fuels the growth of more data and content. And third is the emerging cognitive capabilities that we are discussing today. That is actually harnessing data that is beyond traditional analytics, right? All of these three things factors combine, to make these companies successful and create the competitive advantage. Let me go to each one of these in detail, right? Today, if you look at these industries, right, the four industries I'm sharing here, from oil and gas to public safety, energy, and healthcare, right? All of these companies are increasingly becoming digitized. Yep. And they're using this data that they're harnessing to transform their businesses. These companies today know with greater precision where to fuel or where to drill the next oil mine, oil drill, or to understand where the next disease is progressing to, or where traffic is going to form, right? Yet, 80% of the data that you're harnessing is still invisible to traditional computers. These are information related from text to conversation and everything that's captured in sight, sound, and motion. And increasingly, there's even more adoption of devices and instrumentation, or intelligent devices. So when you talk about intelligent devices, these are all devices embedded with software code. I'm sure many of you have heard of the term called software is eating the world, right? What it really means is that the world is being reinvented by software code with these devices which are getting embedded with software code, right? And not only that, and because these devices are embedded with code, they are also enabling connecting with other devices, operations, applications, and processes, right? And even generating even more fuel for data, right? But having done that, right, it's come to a point where all of this data has gone past the capability of traditional analytics, right? And this is where I think the cognitive systems are changing the dynamics of that. And the way they go about doing that is understanding, reason, and learn. This is how we term it in IBM. And what I mean by understand, reason, and learn, right? And if you think about understanding, right, there's really about two attributes you need to think about, right? The first attribute is, how do you navigate the complexities of human speech? Understanding the nuances in language, or how we express ourselves. The second attribute is how do you interpret or putting content into context? This is not easy, right? Give you an example. If I were to say, I was caught in a jam this morning, most of you would be able to infer that I was probably talking about the traffic jam in Jakarta. But if you had a system that was not so smart, it was probably thinking about my breakfast or the spread I had, the red jelly thing called jam, right? So that's on understanding. Reason. The second part of reason is often we are given information that's incomplete. We have to infer on the data and then extract what is required for the purpose, and that's reasoning with a purpose. That means generating a hypothesis and proving the theory, right? And finally, learning. And this is where I think cognitive systems are fundamentally different from traditional computing systems today, right? If you look at today's existing computers, right, they are all hard-coded with business rules and logic, and they follow a particular decision tree format, right? Whereas cognitive systems are different, are completely different. They, like what Jonathan described earlier on, right? These are systems that progressively get smarter. As with every outcome, with every action, with every interaction, with every new piece of information, they are getting smarter and smarter, right? So if you think about the value of cognitive systems versus current traditional systems, if you look at a CRM system or a ERP system, these systems over a period of time, decrease in value because the functionality is not as good as what the current technology is. Whereas systems like cognitive systems actually increase value over time because of the amount of learning they do over time. Now, so all of this, three things I've described, combine to create the competitive advantage that is driving a lot of this business today. And if you look at this, this is what I call a supply chain of cognitive business, right? And here, if you think about it, right, in the last several decades, right, we have been digitizing the world, right? We have been instrumenting it, we've been interconnecting it, and making it more intelligent, right? And we've been applying sensors and devices into application, products, operations, and processes, right? Creating connected cars, satellites, factories, all of that, right? But these are all the elements you see here that drives this supply chain for cognitive business. Obviously, you've got the sensors, which generate the data. The analytics is applied on the data, which transforms to information. And this is the point where the information is being produced is so vast and so great that I think we've reached an inflection point where there's so much information out there that we cannot use it productively. And this is where I think the cognitive system comes to help, and help in the way of extending our ability, extending our expertise, extending our knowledge by harnessing that vast amount of information. So, if you think about what we just talked about, right, you'll see that really, this is what we see is a cognitive system like Watson that is partnering with man to deliver additional capabilities that we're not able to do today by ourselves, right? So it's extending expertise and knowledge. Now, it's also important to know that the skills that cognitive systems provide and what we have are complementary, right? Humans have skills that allow us to learn, discover, and make decisions, right? We have common sense, hopefully. We have moral values. We also can dream up ideas and make generalizations of, things, even when there's only, when we don't have complete information or when certain clues or information is missing, right? Now, on the other hand, also, because of the way that we have grown up, right, where we are educated or in a society, we also have, unconscious bias towards making decisions, right? This is, again, places where, cognitive systems complement humans and machines to extend, the way we look at things, the way we look at the world, and how we make better decisions. if you, so let me get into the part where, how we apply this technology with your respective industries. Today, Watson is in 45 countries, 45 countries, 20 industries, and in 9 languages. And by the end of the year, we have a path to reach 1 billion consumers, and hopefully many through you. And in the next couple of slides, or minutes, I want to share with you three use cases, or 3 different use cases used in 3 different industries on how we've applied the Watson technology to create that competitive advantage for companies and for individuals. The first is a use case that I'm calling expertise at scale, right? And I'm going to refer to the healthcare industry. Perhaps there's some people from the healthcare industry or associated with healthcare here. If you know the healthcare industry, healthcare is one of those industries which is very, very data intensive. I'll just share some statistics with you, right? In 1950, they estimated that the medical knowledge would double every 50 years. In 1980, they estimated it will double every 7 years. In 2015, they're now estimating that medical knowledge doubles every 2 years. And that is the amount of medical literature that's being put out in terms of research and treatment out there. If you think about it from a physician's point of view, a doctor's point of view, he has to spend 160 hours a week trying to read and keeping up with this material. And if you go back and you refer back, on an average, these doctors are only able to spend 5 hours a week. So they need to spend 160 hours, but they're only doing 5 hours a week. So it's impossible to keep up with all the advances that are happening in the medical world or the healthcare world. So what we did was, going back a few years, we decided to put Watson to work in the healthcare industry. So we worked with a number of top cancer centers, and we focused on a specific area of health, which is treatment of cancer and the research in cancer, oncology, right? And we worked with organizations like Memorial Sloan Kettering to develop a cognitive system that analyzes data and provides evidence-based treatment options to these oncologists, right? So that they can provide better and individualized healthcare treatments for the thing. And today, if you look at Watson for oncology, right, it has consumed 15 million pages. All right. So by the way, just a footnote there. The technology on Watson actually consumes about 800 million pages a second. So today, Watson for oncology has consumed 15 million pages, which is about 200 medical textbooks, 300 medical journals, right? And out of that, we're using that technology to help organizations across Asia Pacific in countries like Japan, China, Thailand, India, working with medical centers and hospitals in providing expertise to these doctors to help provide personalized health care. Now, let me try and bring that in context, right, into Indonesia, right? And I did some research, a little research in Indonesia. I found that the 3 biggest causes of death in Indonesia is stroke, heart disease, and diabetes. All 3 contribute to 40% of the deaths in Indonesia. Now, all of these three diseases can be easily treated if diagnosed early. And if you had a system like Watson available to health specialists, heart specialists, let's say from Jakarta to Bandar Aceh to Makassar, each one of them having access to the most relevant and updated information, they can provide the best health care to every single patient with the best diagnosis. And that's the power of the technology from an ability to extend the expertise of this specialists or doctors, right? And again, the ability to personalize expertise at scale, right, is, I would say, can apply to any other industry. For example, wealth management advisor in banking, call center agents in telcos, or even cybersecurity specialists across industries. All of that, you can apply the ability to deliver expertise at scale. Next, let me move on to another use case, personalizing at scale. And here I want to touch on the education industry. And I think it's very relevant here, right? Let me come back to most of us here, right? Most of us, when we went through school, right, we had teachers who had to deliver a curriculum or set of syllabus, a very defined set of syllabus, irrespective of what the student's capability was, right? We had classmates who could cope well, and we also had classmates who had a hard time keeping up. And really, you know, the challenge is because each one of us learn and acquire knowledge differently. And the teachers don't have the resources or the time to actually figure out what each student's capability is and customize the teaching to that specific student. But this is where, you know, a system like Watson can help. Today we are working with multiple schools and institutions across the world to collect data about students' learning styles, preferences, their aptitude, and then combining with things like academic data, social media, as well as behavioral data, and providing the insight to make suggestions to the educators for them to cater to every specific student in their classroom, right? And the curriculum is optimized based on, and as they use the system learns more about the student and customizes that to that specific student. Again, this is applicable to any other industry as well. The ability to personalize in banking, customers, telco, or governments, civil service, all of that is applicable. Now, let me get to a very different part, and this is actually my last use case here I wanted to share, is discovering at scale. This is the ability to recognize patterns and relationships in vast amounts of data. And here, what I'm going to do is that I'm referring to the creative industry, okay? And a lot of people will not associate machines to being creative, right? Who would thought that machines and being creative, that's not something that goes hand in hand, right? But actually, we've been working, Watson's been working in the creative industry for a while now. We are now creating new recipes, cooking recipes. We are into fashion design. We are also creating trailers for movies. If you've seen the movie Morgana, that trailer was developed by Watson. That means we looked into what keeps attracts people to watch a movie, and we developed that trailer as well. And lately, we've also put Watson to work in music. And that's what I wanted to share with you, is the work that we've done here. And instead of me talking about it, I wanted to show a video clip on how Watson worked with Alex the Kid, a music producer, to create a hit song. And this hit song, after being released in 2 days, was in the top 100 US Spotify charts, right? And can we play the clip here?
I found music when I was 19 and it completely changed everything. My perspective, my friends, just the way I looked at the world, and it just made me a different person. It's absolutely everything in my life. I'm Alex the Kid, and I've been told to say I'm a Grammy Award-winning producer. I love understanding human emotions because it's very complex. You know, why people feel the way they feel, what actions they take based on that feeling. My favorite question to ask people is why. I take inspiration from all different types of places, but ultimately it's just from living life.
When we first met Alex, he was interested in exploring culture and music on a deeper, more emotional level.
When we talk about illuminating data, what we mean is that we're visualizing it in a way that we can understand it and relate to it.
Very impressive.
In culture, Watson analyzed millions of lines of text, Wikipedia articles, New York Times front pages, social media, blogs, and more, finding the most pervasive themes and uncovering the way people felt about them. Watson also analyzed the lyrics and composition of over 26,000 top 100 Billboard songs, uncovering hidden patterns in both song structure and emotion.
It's almost like having a million of yourself reading a million books at once and a million articles and understanding social media and just conversation in general. I could never do that.
Once Alex began the music making process, we gave him a prototype of something we're developing, called Watson Beat. It understands and deconstructs music and then allows artists to change it based on the moods they want to express.
I always say I don't really play instruments that well. I play the laptop extremely well. Technology is paramount, definitely to my process. And being able to collaborate with Watson, he just took everything to another level. The data from Watson showed me all these heavy emotions millions of people felt around the world. Then I kind of started thinking about heartbreak and just how it's so universal and how everyone goes through it on some level. So it's a very uniting thing.
We were two dumb kids, full of grand ideas.
Hopefully when this is being sung by 60,000 people in a stadium, everyone's singing the same lyric, but they're all singing about something slightly different. But they're all there as a community, kind of feeling each other's pain in a joyous way. Working with Watson's been great because it allowed me to create something that I probably would never have done without him.
It's not easy. It's not easy breaking your heart.
Right. With that, I just wanted to end with some experience or sharing that I want to have with you guys right here is, there are five things that five things we learned as we develop cognitive systems across the number of years, right? Five important things that you need to take note when you're trying to implement cognitive systems. The first, right, it's not about putting a speech to text in front of a search engine. No, it's about machine learning, natural language processing, deep learning, deep vision, all of that combining to deliver a cognitive system that extends our expertise and knowledge. The second is transparency. I think it's really important for us, and we discovered that, is that the data that is being used, we need to be open about it in terms of sharing who trained the data, what is the source of the data, and what is the data being used for. Third is we really think that a cognitive system should be domain specific or industry specific. That means trained by the experts who are in that industry. The fourth, it must be available in the cloud. And here it's because that should be available to everyone to use. It has also be in a hybrid cloud environment because a lot of times you need to integrate that knowledge and information with things that sit behind your firewalls, right? And fourth is, fifth is it has to be on an open platform. And open because you cannot have one or two people innovating on the platform. You need to have an ecosystem sitting on top that is using it to innovate that platform, right? With that, I just want to say thank you for inviting me to keynote here, and I hope you enjoy the rest of the conference. Terima kasih.